Hi folks, we're going to take a look at number 7 from the Unit 3 review. Okay, and these are both questions that involve finding a quadratic model or a quadratic function based on data from a table of values. Okay, so there's two options that we have. We can either find a model based on the vertex form, so that would mean trying to find a good candidate for the vertex within the data, or using factored form, which would mean finding good candidates for the zeros. So to look for the zeros, you need to find y values that are very close to 0 or equal to 0. And I don't see anything really here that's a good candidate. Okay, so I look at the y values and I see that they're going up, then coming down. So I know it's opening downwards. And I look at the biggest value, 13.75. So that's a good candidate possibly for the maximum. But we need to check what's happening on either side of this number. Is it symmetric? So if I go just above, I see 12.89, and then if I go below, 12.95. They're not equal, but they're quite close. So let's go another step. If I go down by 2 steps, I see that I've got 9.9, and here I go up by 2 steps, 9.8. Again, very, very close. Let's go again, 3.95, 4.1, very close. So this is a very good candidate for the vertex. So for part A, what I'm going to do is I'm going to use vertex form. Okay, and what I'm going to use as my vertex will be, what do we have? 1.5 and 13.75. Okay. So once I have my vertex, I can input this into the vertex form of the equation of a quadratic. So a times x minus h squared plus k. Okay. So now I don't know the a value yet, but I do have a value for h. The x value of the vertex is here 1.5. Okay. And I have a value for k, 13.75. Okay. So the only thing I'm missing for my equation is this value of a. And what we can do is we can take any point on this table of values, other than the one we've already used, which is the one for the vertex, and use that to help find the value of a by inputting x and y. So I'll take what seems like the easiest one. I'll input 0 and 3.95. So I'll input this point into my equation. So here, wherever I see y, I'm now going to replace it by 3.95. Okay, a is still the value I don't know. X I can now replace by 0. And then plus 13.75. And what I have now is an equation I can solve, an equation for a. Okay, so the first thing I'll do is I'll bring the 13.75 to the other side. So 3.95 minus 13.75, okay, equals a times, well, 0 minus 1.5 is just negative 1.5 squared. Okay, and now let's start cleaning this up here. So we've got 3.95 minus 13.75, so 3.95 minus 13.75, and that gives us negative 9.8. Oops, 9.8. And then on the other side, I have negative 1.5 squared. Okay, so let's calculate that. We've got negative 1.5 squared, and that's 2.25. Okay, so here we've got 2.25 times a, and then the last step is just to divide both sides by 2.25. So negative 9.8 divided by 2.25. Okay, let's calculate that. 9.8, or sorry, negative 9.8, so negative 9.8 divided by 2.25, and that gives us 4.36, negative 4.36. So a here is equal to negative 4.36. Okay, not surprisingly, the a value is negative, since we did say that the parabola seems to be opening downwards. So now I can give my final answer, which is the quadratic model. So y is equal to negative 4.36 times x minus 1.5 squared plus 13.75. Okay? Now, if we wanted to, we could expand this to get it in standard form, but on the test, I'm perfectly fine if you leave it in this form here. Okay, so now let's take a look at part B. Okay, so let's bring part B here. Okay, and we see in part B that, well, this is, first of all, I notice that the numbers are going down and then coming back up, so it makes sense that we've got a minimum. And I see this seems to be the smallest value, but when I look on either side of it, these two numbers are not particularly close. Okay, and then if I go up another step and down another step, I see those are not particularly close. So it doesn't look like using vertex form is going to be useful, but I do notice here a y value of 0. So I know that 0.5 is an x-intercept. And if I go a little further up, well, 0.01 is not exactly equal to 0, but it's very, very close. Okay, and given that these are not necessarily going to be perfect parabolas, we're okay with using a number that is close. So it looks like what we can use as our x-intercepts are negative 1.5 and 0.5. Okay, so this is how we'll start it off. Okay, last time we worked with the vertexes, the vertex. Now we'll work with the x-intercepts. Okay, and what we have here are negative 1.5 and 0.5. Okay, so because we have the x-intercepts, we're going to work with factored form. So a times x minus m times x minus n, and let's input what we know. Okay, so we have one x-intercept, so x minus negative 1.5. So when we subtract a negative number, it becomes an addition, so that'll become x plus 1.5, and then the other one will be x minus the other x-intercept, 0.5. Okay, and as before, what we're missing here is the a value. Okay, so I'll have to pick a number. I won't pick, the only thing I can't pick are either of the zeros, so I'll just pick the first one that's on the list. Okay, so I'll input the point negative 2 and 0.38. Okay, so here wherever I see y, I'll input that as 0.38. Okay, equals a times. So here we have negative 2 plus 1.5, and then here we have negative 2 minus 0.5. Okay, so let's clean that up. So nothing to do on the left-hand side yet, so I'll just leave that there. And now on my calculator, let's see if we can get some light on it. So here we've got open bracket, so negative 2 plus 1.5. Okay, close bracket, times, open up the next bracket, negative 2 minus 0.5, close bracket, and when we do that, we get 1.25. Okay, so here we have 1.25 times a, and the last step will just be to divide both sides by 1.25. Okay, and what we get as our a value here is 0.38 divided by 1.25, and we get 0.304. So not surprisingly, this is a positive number since the numbers are going down and then back up, so it opens upwards, and so our final answer here will be y equals 0.304 times x plus 1.5 times x minus 0.5. Okay, and there's our model. So again, just to recap here, when you've got data in a table of values, you either have to look for a vertex, so a point that could act as a vertex, or you need to look for two zeros and then use the appropriate form in either case. Okay, that's it for this one here.